Hi guys, so the topic today is quadratic simultaneous equations. So a quadratic simultaneous equation looks something like this. So you have an x squared, so you might have 5x squared plus y squared equals 56, and then you'll also have a linear equation which is like 3x plus 2y equals 10. And then you have to work out solutions that work in this situation. So step 1 is what we're using substitution for this, which is you can see a basic substitution in the linear simultaneous equations video, but substitution is basically finding a definition for y or x and then subbing that into the quadratic equation. So for example, if you had x squared plus y squared equals 6, then you had 3y plus x equals 9. You change this one to x equals 9 minus 3y, and then sub in that x into the x squared, square this, and you'd then only have y's in the equation, and you could just rearrange it and solve it like a normal quadratic equation. So the first step there, was to make x or y the subject of this equation, and then you sub into the quadratic, and then you just solve the quadratic, and that's you done. So the first practice. This is already done nicely, so you can pause the video now if you want to have a go. But at the moment we've already got the definition for y. So that means here you can sub in y from the first equation to the second equation. So at the moment you have y equals x squared, but we know that y equals x plus 2. So that means x plus 2 equals x squared. So then your equation is x squared minus x minus 2 equals 0. And then you just solve that with the quadratic formula or on a calculator. So I'm going to do it on my calculator now. And the answer for that is so x either equals 2 or x equals minus 1. Then you sub in the x value back into one of these equations. So for x equals 2, y equals x, so sub in 2 plus 2, so y equals 4. So that is one pair. Now for x equals minus 1, y equals minus 1 plus 2, y equals 1. So there are our two pairs of solutions for those two equations. The next practice, again, is quite easy because they've already given us y here. We don't have to do any rearranging. So we're simply going to plug that y into the second equation, meaning we have x plus 3 equals x squared plus 3x. Now we're going to rearrange that, so we've got x squared, 3x minus x equals 2x, and then minus 3 equals 0. Plug that into calculator or use the formula, and we get x equals 1 and x equals minus 3. You could also factorise this, normal factorisation. That would also work. So then we put x equals 1 and we find the y value. So if x equals 1, y equals, sub in the 1 plus 3, so y equals 4. And then the other one, x equals minus 3, y equals minus 3 plus 3, y equals 0. Last example. This one we've only got to do a little bit of rearranging. So this equation now becomes y equals 1 plus x. Now sub that into the quadratic. So 1 plus x equals x squared minus 3x plus 4. So the quadratic equals x squared minus 3x minus another x minus 4x plus 3 equals 0. The two solutions. X equals 3, x equals 1. So then we use that, so x equals 3, y minus 3 equals 1, so y equals 4. Then x equals 1, y minus 1 equals 1, y equals 2. Two sets of solutions there as well. Now quickly just touch on graphing. So as I said with the linear equations, the points where they cross are the solutions. So the solutions to these simultaneous equations is about 1. So this is x equals 1, y equals 2, x equals 3, and y equals 4. So that's one pair and that's one pair, and that is just the coordinates of the intersections there. And then just to remind you, this is a circle, but that is also a quadratic equation. So you can have a quadratic there, and then the solutions here would be there, and the solutions here would be there. So if you get given a graph, the solutions are just where they cross over. Please like and subscribe, we've got new videos weekly.